Hello everyone. Today in this tutorial, we will discuss about quicksort algorithm. This is the outline of quicksort algorithm. What is quicksort algorithm in data structure? When to use quicksort? Explanation of quicksort algorithm. Example of quicksort. Time complexity of quicksort. Advantages and disadvantages of quicksort and applications of quicksort. What is quicksort in data structure? So, quicksort is basically an application of divide and conquer approach. In this problem, we are going to divide a problem into two sub problems and repeatedly we will solve these two sub problems until we obtain the final output. Quicksort is a sorting algorithm based on the divide and conquer approach that picks an element as a pivot element, and depending upon that pivot element, it is going to divide the given elements in two parts and placing the pivot elements in its correct position in the sorted array. So, what is divide and conquer approach? So, basically divide and conquer approach, we follow three number of steps. Number one is divide, that means we are going to break a problem into two sub problems. So, divide means this involves the divide or partition of problems into smaller sub problems. So, actually the time complexity of divide is a constant time that will be indicated as order of 1. Conquer. Conquer means solve the sub problems by calling recursively until solved. That means we will repeatedly solve the sub problems until we get some output. So, in case of quicksort, we are going to divide the array into two parts and each part will consist of near about n by 2 number of elements. So, the recursive function will be defined as 2 t n by 2. So, we can say that in conquer process the recursive function will be defined as t of n equals to 2 t n by 2, where t indicate the time complexity, 2 indicate the number of sub problems and n by 2 indicate each sub problem or each part consists of n by 2 elements. Combine. Finally, we will combine the sub problems to get the final solution of the whole problem. The time complexity of combine will be defined as order of n. So, here is the 3 steps divide and conquer process for sorting and typical array A of P to R. That means, an array is given that P indicate the starting index number of the array and R indicate the last index number of the array. So, in divide process, we have to partition or rearrange the array, that is A of P to R, into two possibly sub entities or sub arrays, that is A of P to Q minus 1 and A of Q plus 1 to R, such that each element of A of P to Q minus 1 will be less than A of Q and each element of A of Q plus 1 to R will be greater than or equals to A of Q. That means, we have to provide the position of the partition element in such a position that we can divide the entire array into two sub arrays and the left side sub array consists the element which is less than value of A of Q and the right sub array will consist the element value which will be greater or equal to A of Q. So, compute the index Q as part of this partitioning procedure. Now, second step conquer, that means we have to arrange or sort the two arrays A of P to Q minus 1 and A of Q plus 1 to R by recursive call to quicksort. Now, third step is the combine. Since the sub arrays are sorted in place, now work is needed to combine them, so that we can obtain the final output. So, now the entire array A of P to R is now sorted after performing these 3 steps. So, this is the quicksort algorithm. So, here array A indicate the given array, int P indicate the starting position of or starting index of that particular array, or int R indicate the last index number of the given array. So, in step number 1, first we will check the condition. That means, if the value of P is less than value of R, that means, if there are more than one element present in the given array, then we will go to step number 2. In step number 2, we will call the partition function, that is partition APR. Separate algorithm is present for this partition function. Whenever we will call this partition function, the output of this partition function will be assigned to the variable q. Depending upon this partition value or q value, we can break the problem into a number of sub problems. So, after completion of step 3, again we will call the quicksort for A of P to Q minus 1, and in step number 4 again we will call the quicksort A of Q plus 1 to R. That means, after obtaining the value of Q, we will call quicksort 2 times. To sort array of all, quicksort A comma 1 comma length of A will call. Here 1 indicate the starting index number of the array and length of A indicate the total number of element present in the given array, or we can say that this length of A will be assigned to variable R. This is the quicksort partition algorithm. So, here in step number 1, the value of A of R, that means the value present at rth location will be assigned to variable x. That means, we are going to select or choose the pivot element. In step number 2, the value of P will be decreased by 1 and this decreased value will be assigned to variable I. In step number 3, a for loop is present. That for loop will consist step number 4, 5 and 6. This for loop will continue with variable j and this for loop will continue from P to R minus 1. In step number 4, we have to check if the value of A of j is less than equals to x. If this condition is true, then the value of I will be increased by 1 and that increased value will be assigned to variable I. And in step number 6, now we are going to exchange the value of A of I with A of j. That means, step number 4, 5 and 6 will continue until the for loop is going to execute. That means, this for loop is true if we are going, this condition is true. That means, the condition that present in step number 4 is true, then we are going to execute statement number 5 and statement number 6. After completion of this for loop, statement number 7 is going to execute. That means, after processing the for loop, we will exchange the value of A of I plus 1 with A of R. And finally, in step number 8, we will return the value of I plus 1. And this output of this quicksort partition will provide the value whatever we will obtain from this algorithm will be transferred to the variable that was the variable q that was present in step number 2 of quicksort algorithm. This is the example of quicksort. In this given array, some elements are present 2, 8, 7, 1, 3, 5, 6 and 4. That means, there are 8 number of elements are present and we are going to arrange or sort these elements using quicksort algorithm. So, in the right hand side the algorithm is present and here, so the value of P will be 1 because the value of P indicate the starting index number of the array and R indicate the last index number of the array. So, there are 8 number of elements are present in the given array. So, the value of P will be 1 and the value of R will be 8. As per the partition algorithm, the value of x now we are going to calculate, because in step number 1 the A of R value will be assigned to x. A of R means the value of R is 8. So, the value present at the 8th position is 4 and that 4 will be assigned to variable x. So, here we obtained the value of x is equals to 4. In step number 2, the value of P will be decreased by 1. So, initially the value of P is 1, now P will be decreased, that means, the I value will be 0. As per the step number 3, the for loop will start from P, that is from 1 and it will continue up to R minus 1, that means 7. So, for loop will consist or for loop will continue from 1 to 7. Now, we will process for loop for j value equals to 1. So, here now we are going to process the for loop with j equals to 1. So, here the array is given 2, 8, 7, 1, 3, 5, 6, 4. This is the initial array. So, here what are the values required to perform this algorithm? The value of x is equals to 4, the value of r is equals to 8. Now, I value we have already obtained, that is 0, the value of j is equals to 1 and the value of a of 1 equals to 1 equals to 2. That means, the 2 is present at the first position of the array. Now, we are going to step number 4. So, here if a of j is less than equals to x, now we are going to check the value of a of j and x. So, a of j means a of 1 is equals to 2 and the value of x is 4. So, 2 is less than equals to 4, the condition is true. So, if the condition is true, now we are going to execute step number 5 and step number 6. So, then the value of I will be increased by 1. So, initially it was 0. So, now it will increase to 1 and we are going to swap the value of a of 1 with a of 1 using step number 6. So, that means we are going to swap or exchange the value of a of 1 itself with a of 1. So, there will be no changes in the given array. So, the final output will be 287135664. So, this is the array obtained after processing the value or processing the for loop for value j equals to 1. Now, we will increase the j value to 2. Now, we are going to process the for loop with j equals to 2. So, here the value will be x equals to 4, r equals to 8, I we have already incremented. So, it will be 1, the value of j equals to 2 because we are going to process for it for j equals to 2 and the value of a of 2 equals to 8. Now, we are going to implement step number 4. So, here the value of a of j is 8 and the value of x is 4. Now, we are going to check the condition. So, 8 is less than equals to 4, the value is false. So, then we will skip the step number 5 and step number 6 and we will process after completion of the process j equals to 2. So, there will be no changes in the given array, the array will be 287, 1, 3, 5, 6 and 4. Now, we will increase the value of j from 2 to 3, now we will process for j equals to 3. So, here is the process for j equals to 3. So, the array is 287, 1, 3, 5, 6, 4. So, the values are x equals to 4, r equals to 8, I equals to 1, j equals to 3 and the value of a of 3 equals to 7. Now, we are going to execute the step number 4, that means a of j is less than equals to x, we have to check that. So, here the value of a of j means a of 3 equals to 7. So, 7 is less than equals to 4, the condition is false. So, if the condition is false, now you will skip the step number 5 and step number 6 and the output after processing the j equals to 3 will be defined as 287135664. So, there is no exchange or swapping occur for this for j equals to 3. Now, we will process or check for the value of j equals to 4. Now, j equals to 4. So, here the partial array is 287135664. Now, the value of x is 4, the value of r is 8, I is 1, j equals to 4 and a of 4 equals to 1. Now, we will execute the statement number 4 or step number 4. Here, we are going to check the value of a of j is less than equals to x or not. So, the value of a of 4 is 1 and the value of x is 4. Now, 1 is less than equals to 4, the condition is true. If the condition is true, now we are going to execute statement number 5. In that case, the value of I will be increased by 1. So, previously the value of I was 1, now I will be increased from 1 to 2 and now we will swap the value of a of 2 with a of 4. So, first time in this algorithm, we are going to swapping the two elements, that is a of 2 and a of 4. So, after swapping, that means after completion of j equals to 4, we will obtain the partial sorted array is 217835664. That means, we are going to process the value of j equals to 5 on this partial sorted array. For this, the value of x will be 4, r value will be 8, the value of I will be 2, the value of j is 5 and a of 5 will be 3. Okay. So, now we will check the statement number 4, that means, we are going to check the condition that a of j is equals to less than equals to x or not. So, the value of a of 5 is 3 and the value of x is 4. So, 3 is less than equals to 4, the condition is true. If the condition is true, now we are going to update the value of I. So, the value of I will be 3 and now we are going to exchange or swap the value of a of 3 and a of 5. So, after swapping, we will obtain the partial output and using that partial output, we will process the value for j equals to 6. So, after swapping a of 3 and a of 5, the partial sorted array will be 2, 1, 3, 8, 7, 5, 6 and 4. So, now the value of x is 4, the value of r is 8, I equals to 3, the value of j is 6 and here the value of a of 6 is equals to 5. So, now we are going to check the condition number or statement number 4. Here the value of a of j is equals to 5. So, we will check 5 is less than equals to 4, the condition is false. If the condition is false, now we are going to skip the statement number 5 and 6. So, the output will be same as it is. Now, we will increase the value of j from 6 to 7. So, here now we are going to process the value of j for 7. So, the partial output array is 2, 1, 3, 8, 7, 5, 6, 4. So, the value of x here 4, r equals to 8, the value of I is 3, j equals to 7 and the a of 7 is equals to 6. So, here now we are going to check if a of j is less than equals to x or not. So, the value of a of 7, that is 6 and the value of x is 4. So, 6 less than equals to 4, the condition is false. If the condition is false, then we will skip the step number 5 and step number 6 and the output after processing j equals to 7 will be defined as 2, 1, 3, 8, 7, 5, 6 and 4. So, we have completed our for loop. Now, we are going to execute the step number 7 and step number 8. In step number 7, we are going to exchange the value of a of I plus 1 with a of r. From the previous steps, we obtained what are the values? The value of x was 4, the value of r is 8, the value of I is 3, the value of j was 7 and the value of a of 7 is equals to 6. Now, using step number 7, we have to exchange a of I plus 1 with a of r. That means, the value of I was 3, now it will increase to 3 to 4. That means, we are going to exchange or swapping a of 4 with a of 8. So, what will happen? So, the partial output after completing the swapping process, that means a of I plus 1 with a of r, the output will be 2, 1, 3, 4, 7, 3, 6, 8 and step number 8 will return the value of I plus 1, that is 4. Okay. So, after processing all the steps, we obtained the value of I plus 1 is 4 and this 4 will be transferred to the variable q that present in the quicksort algorithm. So, using quicksort partition algorithm, return the value 4 and this value will be assigned to variable q. Now, we are going to divide the array into two sub arrays. So, the value of q is 4. Now, we are going to consider a left sub array, that is from p to q minus 1 and the right sub array a of q plus 1 to r. So, now the value of q is 4. So, we will divide the two sub array into a of 1 to 3 and a of 5 to 8 and the position of the pivot element is 4. In the graphical representation, here 4 indicate the position of the pivot element, that means the index value is 4 and the value present at the pivot element is also 4. And here the p of q minus 1, that is 1 to 3 and q plus 1 to r, that is from 5 to 8. So, after getting the value of q, we will call quicksort, that is a p q minus 1 and also second quicksort upon a of q plus 1 to r. This process will continue until we satisfy all the condition. So, what is the best case running time of quicksort? In the most even possible, whenever we are going to divide or break the given array into two sub problems. So, whenever each size is consist near about n by 2 number of elements, we can say that this is the best case scenario. So, in the most even possible split, partition produce two sub problems, each of size is not more than n by 2. Since one size is n by 2 and one size is n by 2 minus 1, that is we have mentioned in the float symbol, in this case quicksort runs much faster. So, the recurrence equation will be defined as t of n equals to 2 t n by 2 plus n. So, here 2 indicate we are going to divide the problem into two sub problems, n by 2 indicate each sub problems consist near about n by 2 elements and this n indicate the final combined time. So, now this recursive equation is given, t of n equals to 2 t n by 2 plus n. Now, we can use master method to solve the given equation. So, the master method standard equation is t of n equals to a t n by b plus f of n. So, what is the procedure to solve the master method? first of all we are going to compare the given equation with the master method standard equation. So, here the given equation is 2 t n by 2 plus f of n and the master method standard equation is t of n equals to a t n by b plus f of n. So, if we compare the two equations, then we will obtain the value of a, b and f of n. For this particular problem, the value of a is equals to 2, the value of b is equals to 2 and the value of f of n is equals to n. So, using master method equation, now we are going to calculate n to the power log a base b. So, we have already calculated the value of a and b. So, here we will put n to the power log 2 and base 2, because we have already calculated the value of a and b. So, n to the power log 2 base 2, that will be indicated as 1. So, n to the power 1. So, the value of n to the power log a base b will n. After calculating the value of n to the power log a base b, now we will compare the value of f of n with n to the power log a base b. So, both the values are equal, because the value of f of n is n and the value of n to the power log a base b is also n. So, in master method equation, if the two values are equal, then the recursive function will be defined as t of n equals to order of f of n into log n. So, what is the value of f of n? That is n and log n. So, the time complexity of quicksort in best case will be defined as order of n log n. Now, we are going to calculate worst case running time. So, the efficiency of the quicksort algorithm very much depends upon the selection of the pivot element. Let us assume that the input of the quicksort is in a sorted sequence and we choose the leftmost element as a pivot element. In this case, we will have two extremely unbalanced array. One array will have one element and the other array having n minus 1 elements. So, similarly, when the given input array is sorted in reversely and we choose the rightmost element as the pivot element, the worst case occur, because in this case the left hand side will consist of one element and the right hand side will consist of n minus 1 element. So, again in this case the pivot element will split the input arrays into two unbalanced arrays. So, this is the graphical representation of worst case analysis. Here the total n number of elements are present and if we consider the leftmost element as the pivot element, then the rightmost side will consist of n minus 1 element. So, again we will pick one element as the pivot element, that element we will consider as the sorted element, then n minus 2 element will be present at the right side. So, this process will continue up to we obtain the final output. So, all the numbers in the box denote the size of the arrays or the sub arrays. Let us consider an input array of size n. The first partition called takes n times to perform the partition step of the input size array. Each partition step is invoked recursively from the previous one, given that we can take the complexity of each partition call and sum them up to get our total complexity of the quicksort algorithm. So, therefore, the time complexity of the quicksort algorithm in worst case will be defined as n plus n minus 1 plus n minus 2. This process will continue up to 2 up to 1. So, that define an equation n into n plus 1 divided by 2. If we solve n into n plus 1 divided by 2 minus 1, if we solve this equation, the output will be obtained as order of n square, or alternatively we can create a recurrence relation to compute this worst case complexity of quicksort. So, what will be the recursive function? In the worst case, after the first partition, one array will have one element and the other one will have n minus 1 elements. Let us say that t of n indicate the time complexity to sort n number of elements in worst case. So, t of n here indicates the time needed to partition n elements plus time needed to sort n minus 1 elements recursively, that is will be defined as n equals to n plus t of n minus 1. Again, for the base case, when n equals to 0 and 1, we do not need to sort anything, hence the sorting time is 0. For t of 0 and t of 1, it will be indicated as 0. That will be called as the base case scenario. So, now we are ready to solve the recurrence equation. So, t of n equals to n plus t of n minus 1. So, now recursively we are going to calculate the value of t of n minus 1. If we substitute the value, so t of n minus 1 will be n minus 1 plus t of n minus 2. Again we are going to calculate the value of t of n minus 2. So, the equation will be t of n minus 2 is equals to t n minus 2 plus t of n minus 3. So, again this process we are going to calculate up to t of 3, t of 2 and t of 1, and we know for the base case is t of 1 is equals to 0. So, as a result t of n equals to n plus n minus 1 plus n minus 2 up to 3 up to 1. So, that equation will again generate n into n plus 1 divided by 2 minus 1. So, if we solve this we will obtain the output as order of n square. So, the worst case time complexity of quicksort is defined as order of n square. Now, advantages of quicksort. So, the first advantage is fast and efficient. Quicksort is the most favored user's choice to perform sorting function quickly and efficiently. It allows user to achieve the same result much quicker than other sorting algorithms. Second advantage is cache friendly. The most talked about the feature of quicksort is its in place sorting. This means at the time of sorting the algorithm does not need any additional storage space. Thus, the sorted list occupies the same storage as that unsorted list and the sorting takes place in the given area. Next one is good for parallelization. That means quicksort can be parallelized easily, taking advantage of multiple process or computing resources. By dividing the input array into sub arrays and sorting them concurrently, it can achieve faster sorting time on systems with parallel processing capabilities. Next one is simple implementation. Quicksort's algorithm logic is relatively straightforward, making it easier to understand and implement compared to other sorting complex algorithm. Next advantage is time complexity. Time complexity is the time taken by the algorithm to run until its completion. Compared to other sorting algorithms, it can be said that the time complexity of quicksort is the best one. Space complexity. Quicksort has the space complexity of order of log n, making it a suitable algorithm when you have restriction in space availability. Now, we will discuss about disadvantages of quicksort. So, the first disadvantage is unstable. Quicksort is undoubtedly a faster and most efficient algorithm, but when it comes to stability, you might want to reconsider your option. The sorting algorithm is regarded unstable and it does not retain the original order of the key value pair. Worst case time complexity, as we have already calculated that the best complexity of this quicksort is order of n log n, but the worst case complexity is order of n square. So, this is actually a drawback of quicksort. It usually occurs when the element selected as the pivot is the largest or smallest element, or when all the elements are in the same. These worst case drastically affect the performance of the quicksort. Next disadvantage is that dependency on pivot selection. The choice of pivots significantly affects the performance of the quicksort. If a poorly chosen pivot divides the array into highly imbalanced partition, the algorithm's efficiency may degrade. This issue is particularly prominent when dealing with already sorted or nearly sorted arrays. Next disadvantage is recursive overhead. So, quicksort heavily relies on recursion to divide the array into sub arrays. Recursive functions call consumes additional memory and can lead to stack overflow errors when dealing with the large data sets. This makes quicksort less suitable for sorting on extremely large number of elements that present in the given array. Another disadvantage is that inefficient for small data set. Quicksort has additional overhead in comparison to some other simpler sorting algorithms, especially when dealing with the small data set. The recursive nature of quicksort and the constant splitting the arrays can be inefficient for sorting small arrays or arrays with a small number of unique elements. So, we must have to concentrate that whenever we are going to apply the quicksort on the less number of elements, it will be the most inefficient in small size of data set. So, we have to be careful in that particular time. If the small data set is present, then we will pick other algorithms rather than quicksort. Not adaptive. Quicksort performance is not adaptive to the initial order of the elements. It does not take advantage of any pre-existing order or partially sorted input. This means that even if a portion of the array is already sorted, the quicksort will still perform partitioning operation on the entire array. For that reason, it is not adaptive. Now, we will focus on applications of quicksort. Commercial computing is used in the various government and private organizations for the purpose of sorting various data like sorting files by name, by date, by price, or sorting the students by their roll number, sorting of account profile by given ID or etc. So, whenever we are facing such type of problems, it may be in the government related problem, government sector related problem, or it may be the private sector related problem, then we can select or apply the quicksort. The sorting algorithm is used for information searching, as quicksort is the fastest algorithm. So, it is widely used as a better way of searching. So, rather than the worst case complexity of the quicksort, we can apply or we can pick this sorting algorithm as the most suitable sorting algorithm. It is used everywhere a stable sort is needed. So, next application is quicksort is a cache friendly algorithm, as it has a good locality of reference when used for an arrays. It is tail recursive, and hence all the call optimization can be done. That means, if we are going to focus on optimization process, then we can use the quicksort. It is used to implement primitive type method, and the next application is it is used in operational research and event driven simulations. Also we can use the quicksort technique or quicksort algorithm. So, conclusion. So, overall quicksort is a powerful data structure algorithm with advantages such as efficiency and versatility. It is an essential tool for developers to have in their belt when dealing with the large amount of data. Quicksort is an efficient, unstable sorting algorithm with time complexity of order of n log n in the best case, and average case time complexity is order of n square. But rather than quicksort is one of the most favorite sorting algorithm, so that we can use this algorithm or we can apply this algorithm in many different scenarios. Thank you very much.